Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Merdad Abdullahi, the community lead and the organizer of this great community. So, let's see who's going to join us today. In the meantime, you can just say hi in the chat and tell us where you're connecting from. And so let's kick it off with no waste. And as usual, I'm going to just share my slides. Arafat, good morning or good afternoon to all, depending on your time zone, for sure. Can't wait for this exciting session. I really love the star schema, who's going to be the guardian of the Azure Cosmos DB and Microsoft Dataverse, or is Microsoft going to create it? Yeah, cool. Yeah, thank you for joining, Arafat, and congratulations, basically, by the way, for your achievement on Microsoft Fabric certification. Well done. So I'm going to share my screen and let's kick it off. Today, the 30 number, actually, Fabric Coffee Station number 38 uh, on June 28th at 12 p.m. my time, Pacific time. And so we are in the Microsoft Learn community, if you don't know us. So it is a great community and the richest place for learning and just enhancing your skills and your knowledge about Microsoft and Azure, tools and products and all the in Microsoft landscape. So there are lots of learning groups in the Microsoft Tech community that you can just join to them based on your interest. It is going to be based on some data, some roles in the Microsoft landscape, or even some tools that you're going to just find them. You can use the short link below, and you can connect your experts and also connect to your peers there. And here it is Microsoft Fabric Cafe. It is a Microsoft Learn community, a learning group in the Microsoft Learn. With over 4,000 members globally, we are focusing on Microsoft Fabric, and we provide learning and support to Fabric users in all levels. Basically, there's a forum for everyone to learn, share, and grow skills together. In this slide, I can just share with you our social links, our YouTube channel, Microsoft Fabric Cafe, and our LinkedIn page, where you can just see the announcements, and on Microsoft Community Group, which is basically we have done some transition from Teams to this Microsoft Community Group, the web-based tech community. You can use that tiny URL /MS Fabric Cafe to join there. It is an open group. Everyone can join. And there's a meetup group with the name of Microsoft Fabric Cafe again. So there you can just show your presence for the sessions, plus rating the sessions once it is done. And we recently moved to Reddit. We just created our page on Reddit to just expand our presence, across the social platforms with the Microsoft Fabric Cafe name again. Just feel free to follow us there as well, and add your questions and start a discussion in both Microsoft Community Group and Reddit to get more support from your peers and from the experts. So there's a code of conduct when you join our sessions, either online or in person. Thank you very much in advance for just adhering to these code of conduct. And the last session with Marcus was a great one. He actually walked us through the DAX and how to apply some secrets. It was a very good thing for beginners, and also for intermediate guys. If you missed that, if you want to rewatch it, feel free to rewatch it on our YouTube channel. It is uploaded there. And for today, we have Marcus, and he's back with another amazing topic: become a guardian of the star schema with Microsoft Fabric. So let me invite him to the stage and let him to kick it off. Hey, Marcus, welcome
Hi.
back to Microsoft Fabric Cafe.
Thank you very much. Yeah. To be honest, I forgot my coffee. It's so hot out there, so I only have a glass of water.
Oh, nice, nice. I have my water now. Sorry.
That's what they always say, right?
Yeah, yeah, yeah. Cool. I was, just in the backstage, I was telling Marcus, just I noticed a book in your background. This site, yeah, in your background. Would you mind to actually sharing that with us? What is it about, and where attend actually learners can find that?
Yeah, this book is like published by Pact last year in June, so it's now out there for 1 year. And it's all about data modeling with or for Microsoft Power BI. So I cover like all the agnostic things. What is a data model? Then what can you do in Power BI? So what's the model view? What kind of relationships? Things like that. And then the last 3 chapters, or more or less parts, are then like showing solutions in DAX, in Power Query, and in SQL, how you can build a data model. So in the first part, I just talk about why you should model it like this. And in the last 3 chapters, I show you how you can use DAX, or you can use Power Query, or you can use SQL to actually reshape the data, so you can solve the issues you might face during your challenge of making any data you get in any data source to a star scheme, and why it's so important, because Power BI is optimized for that.
Awesome. And
Yeah.
today's topic is going to be, of course, part of that, star schema.
Exactly, actually, I do like the very short version, the most like the Reader's Digest version of my book, right? So I will use Power Query for most of the part, and I will use DAX Studio to show you what kind of difference it makes to use this or the other technique. So like, yeah, whatever we have time in like the remaining 60 minutes, that I will cover in leftovers. Yeah, I will show you
Okay,
as much as I
awesome.
can.
Awesome. And later, maybe you can just share the link. And of course, the title of that is visible on the screen, but is data modeling within Microsoft Power BI. You
Exactly.
can, find it on Pact site, and just go for it.
In the
Cool.
bookstore near
Marcus,
you.
for today, so we are going to hear from you about star schema,
Hmm.
and how we can apply that to our models, for our semantic models. That I'm super excited to just learn from you. Uh, and I'm gonna just hand over the station to you. So I see you've shared your screen. Guys, if there is any question, please feel free to put that in the chat. It's going to be answered for sure during the meeting, or at the end of that, where it is appropriate for sure. And yeah, that's it. The session is yours. The stage is yours, guys. Enjoy it.
Yeah, thank you. Like the session is like about, I want to onboard you as a guardian of the star schema, because there's need for more guardians of the star schema. A lot of troubles I see with my customers come because people ignore to create a star schema, and then they wonder why the DAX statement is so complicated and not even working, or why things are slow. So the root cause for many problems in Power BI or semantic models in Fabric, because it's the same thing, right, is because it's not completely a star schema. And for this session, I want to like start from the very scratch. So it's like a beginner session. I will show you the most important things, how to model anything into a star schema. When I introduce myself, I usually tell people I work with models. They might have different things in mind. This should not be sexistic picture, but like all of my clients, male, female, trends, diverse, they're all beautiful. But what I do is I work with data models. And as you can see on the right part of the screen, this is the model view in Power BI. Obviously, this is not like when I'm finished. This looks way too complicated. A star schema should be more easy, and you should put more effort building the star schema so it's easy to use them. So the goal is that you should learn or accept that data modeling is very, very crucial, especially for Power BI. And there's the star schema, right? We will talk about the star schema because why is the star schema so important? It's not because the star schema is better than any other modeling approach. If you look at Excel, for example, Excel loves to have a wide table. Everything is in one table. It's easy to read for us humans, right? And then you take this as the source for your pivot table, right? So Excel loves white tables. Also, Power BI report builder, if you want to build page-edited reports, you have those data sets. It's called data set, but what it is just a query, right? And it's containing everything you want to show in the report, and you can have more of those data sets, but it's not a star schema. In application databases, they should be in third normal form. This is very important if a database is built for writing access, optimized for writing, and then it should be a normalized schema. Usually, the third normal form, or boys code, or fourth, or fifth, or sixth, but it's normalized. It's split up to different tables, and it's perfect for applications. But it's really, really hard to do queries on it to analyze data because you have to join so many tables. You have to know your way through these tables, and that's why the star schema is so important when it comes to Power BI. In Power BI, Power BI is optimized for the star schema. So people who build the database behind Power BI, the Vertipack engine or analysis services Tabula, no matter what you call it, but this is optimized for a star schema. And if you want to build something in Fabric, you might end up with something called a lake, a direct lake, right? You put everything into the one lake there in Fabric, and then you can build a semantic model consisting of those tables in the lakehouse. And my fear is that people make the same mistake as people tend to when they use Excel. People using Excel, many times I see like every Excel file, every spreadsheet, every table, or what we call worksheet, every worksheet in the Excel file becomes one table in the Power BI data model. Big mistake, right? And the same mistake you could also do in Fabric, that you load something to the one lake and then you just connect a semantic model consisting of those tables, which do not form a star schema. And then you end up with troubles later. The thing is, Power BI is model driven, it's optimized, and I'm convinced that the star schema is also easier to understand for people working with your semantic model because everything is like grouped by topics, right? There's customer, there might be articles or products, there might be regions, there might be measures, right? It's easy to understand as a data model. And the thing is, that's the whole thing, that's the whole buzz, right? Because we could also like stop using semantic models, right? Give everybody in your organization read access to your database, to your data warehouse application database. Share a link on the YouTube video where they can learn SQL, select statements, right? And then off you go, right? Apparently, this did not work out. I think in the 1970s, when they started and developed this SQL language, the structured query language, I think they had in mind that even domain experts could start querying. But as we know, after 55 years now, right, this did not work out. So we need something to help the end users. And that's why we built the semantic models. And I'm also a victim to that. So sometimes I think, I mean, if you build something Power BI, usually people waiting for it, right? Because they build some fancy database, and then of course they want to see the report and create and do the analytics and create the reports on their own. So everybody's waiting for it, right? So there's a time pressure always there, and sometimes I do shortcuts because I think, yeah, then we can finish a little bit earlier, right? But after some weeks, month, maybe after a year, I really regret all the shortcuts because then people ask you to add more things, and the more things you add afterwards, the more it like gets really wobbly, and it doesn't really work out. So please make your semantic model as a star schema. And also, very, very important, if you think about Copilot will solve everything, those LLMs, large language models, they only can work good on your data if there is a a decent semantic model available, because the LLMs do not understand anything about their business. They just do probabilities, right? What could be connected? What does your question mean in the sense? What can I answer? What can I build for? And of course, they need some layer to understand your data. And the semantic model is exactly that layer. So with a Copilot or any other LLM you're using, it's even more important to build a good data model. Otherwise, DAX statements or the reports, they will be like not be in the shape where you can really depend on that. The hard thing is, if you change things later, you most probably will break the report, the existing report. So if you put something out there, right, people start building the reports, putting different columns from different tables there, and then you reshape the semantic model, moving things around. You get a different information to one table, or you split up one table in different tables because you want to make it a star schema, and it was previously not a star schema, then it breaks the report because the reports look up for a certain column in a certain table. If it's not there anymore, then people will get this gray rectangles telling them this visual cannot be shown because there's some mistake in that. So try your best to build a good data model from the beginning. And I fully admit it, right? If I do a quick analysis, if I just load something, I get a bunch of files, right? And I want to find out what's in there and do a proof of concept and try things out. It's not a perfect data model, a semantic model in the case of a star schema, because I know what I'm doing there, right? I'm trying things out, I'm learning. Or if I'm just doing analytics for myself, right? If I download some files from social media and play around with that, what kind of information is hidden in there? Most probably it's not a perfect star schema, but if I publish something and allow others to build their reports on this specific semantic model, then the rules are different, right? Then we have to have a star schema. Otherwise, you will get in troubles more and more because you're building up a technical debt. You're not solving the things in semantic model, so people have then to solve the issues in the report, building their own measures there. Yeah, and suffering from all the backdrafts in the semantic model. So with that said, there's like a anti-patterns. There's like a death of a star schema. But that would be one single table, one white table. Don't do that. It's not a star schema. Or building one table for every source, as I previously mentioned. I almost all the time see this when people tell me that they are loading data from Excel or CSV files, that every file becomes a table. Every file becomes a query in Power Query, right? And later the Power Query becomes a table in the data model. And they're using that because they think this is okay. It is not in most of the time, because what you get from the data source is not a star schema, it's something different. A fully normalized schema, if you're accessing a database, which is then the application database, most probably it's fully normalized. You have to merge things and also header detail usually is split up. You have to move it together. That's a problem I always discuss with my customers. Hard to understand seems to be, but don't have to split into two tables, but make it one table or anything else out there. And just speaking data vault, I'm not really an expert in data vault, but when I did some research, like I found this letter couple of years, I can't remember when it was, but like on datavault.org, or where the page was, it told like works also with Power BI. And of course it works with Power BI because Power BI can work with any database, right? Any data model. But it's not a very good idea to use a data vault as the basis for your analytics. So you have to reshape the data vault into a star schema, right? And not really important what kind of tool you're using, right? The cool thing with Fabric is there's many tools out there, and don't be afraid, right? The idea is not to overwhelm you with all those opportunities, but the idea is if you already have some experience in Python, then use Python or PySpark to model your data, right? If you're coming from the Power BI side and you have already experience in DAX, then use DAX, right? It's okay. I would not do it in DAX because if you want to shape your data in DAX, it means that you load the data as it is, like in the wrong form, and then you use DAX to create your own calculated tables or enrich, add calculated columns. But you can only add things, right? So the wrong data model already is loaded, has to be loaded. It's already there. It's like using all your memory and so on. So it's not the best effort, but before you don't use anything, right? Before you don't model anything, please use DAX or anything else in there, right? Power Query, T-SQL, Spark SQL. Um, just pick your own tool, right? For the demo, I will just use Power Query, right? because I think it's a common thing everybody can use. And as we will see, as I jump over here to my demo environment, the cool thing is with Power BI, if you install Power BI, you already have the sample data I'm using for this demo here. So if you start with a brand new file, which I did here, then it's empty, right? If you try to add some data, it will tell you you have to first get data. And I'm not using that here, but there's this thing where I can use sample data. If I click here, we get this dialog box, and then you can take an online tutorial. To be honest, I looked at it. I'm not very satisfied with that. I think they could do better. And this is what I will show you, right? What I'm doing with that. And if I click then on load sample data, then if you're in any time already you already added something from Excel, this should look familiar, right? There's this navigator, and apparently Power BI has now extracted a file called financialsamples.xlsx on a temporary folder, and then we can click on these names and see what's the content there, right? We have a segment, a country, a product, a discount band, and so on and so forth. And the other one is the very same. As we can see from the icon, this one is the table, right? There's some region on the worksheet which is formatted as a table. Usually I prefer this one, because if somebody adds additional information like below the table or to the right or left or top, this is ignored when I'm using the table. So this is what I prefer here. Then we have this load, transform, data, and cancel. This looks very nice here, but what I tell you is never click on load if there's the option of transform data, because this comes from Excel, right? Most probably it's not a star schema. This would be very, the chance would be very low that somebody exported something which is already a star schema. So you have to work on that. And as you can see here, this is just one table, one by table. One by table cannot be a star schema. A star schema has at least 3 tables, and this is what we make out of. Make out of that in the demo. So you need a date table. I will explain why. You need a dimension table, a filter table, and then you need a filter table containing only your facts. And this is what we will create from this table. So I have a love-hate relationship with this example. The one thing is, I love it because everybody of Newton can redo the demo on your own. You don't have to download anything. You already possessed everything here. I can show how we can, all the steps which are necessary to split up this one big table, OBT, one big table, into a star schema and create a date table. But on the other hand, I'm fearing that people might think if Microsoft comes up with this as an example, this might be a role model. You should model your data like this, and this is not true, right? Don't have one big table. One big table works in Excel, in Power Query, but it's not a very good idea in Power BI. So usually, I would click on transform data, but just to get a baseline how good or bad this data model is, I will click on load, right? So, but usually don't click on load, always click on transform data. So Power Query opens, and then you can reshape, rename the columns, everything, and do everything here. So I'm violating my own rule. Now we see like there's one table here with everything in there. And if I spin up DAX Studio, I can connect it, or I could have to start it from here, right? Let's start it from here. That's already connected. Makes life easier. And DAX Studio is really cool for many things. One thing is that in this in the model view here, you can see here there's like my financials table, but might be a surprise or not, that there's also 2 other tables here. There's a date table template, and there's a local date table, which we did not ask for, right? We just loaded the financial table, and suddenly we have 2 other tables there as well. And if I go to advanced, so advanced doesn't mean that you should be advanced. It's just more information in there. So don't get shied away from advanced here. And few metrics, if I go then to the bottom here and click on the summary, then we get like a bottom line. The bottom line of this data model is 5.3 megabyte, which is small, right? Nobody would be impressed by an example of that. But as we will see, as we reshape the data, we will squeeze this down with every step. So that's the baseline, 5 megabytes. And from the tables, so financial, of course, is the biggest table, cardinality of 700 rows, 5 megabytes. So all of the size goes for the financial table. And I can also like click on this and open up, and I see like the month name costs me like 1 megabyte, right? Also the country costs me 1 megabyte of the file size. And the local date table and date table here is like 730 as a cardinality. And maybe you can already imagine, right? 730 divided by 2 gives 365. So apparently, this is a date table created for 2 years automatically by Power BI. And believe me, you do not want to have this date table because it's really unflexible. And it's then taking up like 110K. Comparable to the total size, this is almost like date table, but still, you do not want to use this because this date table looks very good, right? Because in the date column, we now have like this date hierarchy. Let me zoom in here. And for the date hierarchy, come on, we get then like this very nice columns: year, quarter, month, and day. And believe me, you do not want to have this because if I use this, right, I get this nice hierarchy here. And maybe I will increase the font size a little bit here. Few themes, and then looking for my theme here. Browse themes. Zoom out here. Let me go to my Where is it? Not you. Here we go. Sorry for the delay here. So Power BI, and then I have my themes in here, and then I have to make this a little bit better readable, even without zoom it. So we get this nice hierarchy, right? The year, quarter, month, and day. But if you don't want a quarter, you cannot really, I mean, you can remove it from the visual, but it will always be part of the hierarchy. If you think the quarter would be nice, but if the spelling should be different, no way, you cannot change. Very unflexible, right? So in some point in time in the future, you will have to recreate this date table on your own to satisfy the needs, or like the day here, like it shows just the day number. Many of my users want like the date in here instead of the day number in this hierarchy. If you later change that, it will break your reports. So please change it from the beginning. This feature is all. This is one of the features like 5x5. Not sure if you heard about that, but like Power BI, like next month Power BI gets 10 years, right? But 10 years ago, Power BI was the challenger. There was really cool tools on the market. They're still there, but Power BI, with all these innovations and the speed, they overtook Power BI overtook all the others. But like they have this principle, they say 5x5, so it's 5 minutes. It should take you to onboard you in the sense that you find Power BI, that you download it, that you start it up, and then you load something. And then I can't remember, it's again 5 seconds or 5 minutes. But then you should be impressed, right? 5 seconds to wow you. That means that there's not much time, right? If they need to explain you how to create a date table, this is not doable in 5 seconds. So this is just a marketing tool that this date table is there. And you will find in the documentation of Power BI, learn.microsoft.com, you will find hints to tell you, please create your own date table. Don't use this built-in date table. And so how can I get rid of that? I just go to File, and you should do this as well. You can follow along here. That's your homework, right? Options and settings, and then options. And there's two spaces where you should change a setting. The default here for the current file data load apparently is having this date time, auto date time, the time intelligence. I turn this off, so I get rid of this automatic date table, and I will create my date table on my own, which is not hard to do, as you will see in a couple of minutes. And as a homework for you, please also go to the global section of the data load and turn this off as well. I have turned this on because I have to demonstrate in courses and in webinars like this how bad this is. So I need to have this turned on so I can show you how you can turn it off. But if I would have the freedom, right, I would also turn this off here. Please turn this off. There's no need to have this date table here, right? So I turn this off, and then this hierarchy is now gone, right? And it not doesn't really break my report, but it like shows now not the hierarchy, but something different, right? So if you turn this off later, you might change the behavior of your reports and your visuals, which you do not want to do. And there's also another effect. I'm just running out of time, I think, to show you that. But if you use DAX measures and to refer, for example, to the year field of the hierarchy, there's a certain syntax which only works with this built-in date hierarchy. And if you turn this off, suddenly the measure doesn't work anymore. And then people tell me, yeah, you know what, Markus, we don't use this kind of measures in our semantic model. But I have to tell them, yes, maybe you don't create any DAX measures in your semantic model. You should, but maybe you don't do that, but everybody who can use the semantic model and build reports on it in Power BI, of course, they can create DAX measures in their reports, this report level measures. And of course, they could create measures like this, and you would break their measures. And believe me, if something is wrong with the report, they will not, they will complain you, right? They will not complain Microsoft or anything else. They will complain about the semantic model and that you did not build a good enough semantic model. So please turn this off from the beginning. If we turn this off, of course, now we don't have any data hierarchy, but we can create one, right? In Power Query, in Spark, I can provide you with links to my solutions in there. Just for the easiness, I will use DAX here, right? Again, usually I don't create any calculated tables, because calculated tables, as I pointed out last week when I talked about DAX, calculated tables and calculated columns, they are legacy. The first version of Power BI was the Power Pivot add-in for Excel. Excel 2010, you could download an add-in for that. Since 2013, it's automatically a part of Power BI, of Excel. But in the first versions of this Power Pivot add-in, there was no Power Query. The only way you could create something additional to your data source was using DAX, right? Calculate columns, calculate tables. But now we have Power Query. Don't use calculated tables for that anymore. For the date table, I really can allow to do that, because yes, there's some disadvantage with the calculated tables, but for the dates table, right, it's like 365 or 66 days rows a year, right? For 10 years, it's not even 4,000 rows. So everything which is a disadvantage doesn't really count here. So yes, I will create like this table here with the calendar auto would be one function. And if I jump over to my table view, right, and show you that, then we will see now it will create automatically date table going from the 1st of 2013. Yes, the date is very old in this financial example, covering 2 years, and it will start with the 1st of January and going way back to the last of December of 2014. So this is what this function does. But the disadvantage is here, it will look not only for the date table you have, date column you have in mind, but for all columns of data type date or date time. So if you load, for example, the birthday, or if you have access to a database and maybe they have the system columns there created or valid until or whatever, and maybe they have something like 9999 as the year there, the end of year 999, that the calendar auto like will create a very, very big date table. You don't need that, right? So way better would be to not being depending on this auto thing, but providing your own regions, right? And we can do that, right? We know the data is from 13, and the table should span, sorry for that IntelliSense, hiding my input here. So I can create it like this. So now I'm full control over that. So the output, the table would be the very same as previously, but now I'm control over that. I don't like that very much, because that means that when the new year comes, I have to go to my definition of my date table. Maybe I not have only one semantic model, but several semantic models, and now I have to rewrite all the code, right? Exchanging 13 for 14 and exchanging 14 for 15, maybe, or whatever, right? This is not very nice job to do, because the new year, maybe I want to take a full year, a full week off, not a full year, would also be nice. But taking off the full beginning of the year, going on ski holidays, I don't want to change things here. So what I can do here is I can ask for, please give me the year of the smallest date I have in my financial table, right? There's this financials, where is it? Financial state, and I'm referring to that one, right? And of course, I can do the very same thing for the max. The IntelliSense is not very helpful here. And putting in max, right? So again, the output is the very same, but now I'm very flexible. As soon as the data changes, years are added, years are removed, my calendar table automatically reflects on that. Then we have the date column, right? What we also need is, of course, columns, all right? Not only the date column in the date table, but more things, right? I can then add a new column in here and ask for, yes, I want to have the year column, and this would be the year of my date column, right? As easy as that, and then I get this new column here, year. But with this approach, that means that I have now one DAX query for the dates table, and then I have one DAX expression per column. So if I want to reuse this definition in another semantic model, I have to copy and paste a lot of things, the table and every single column. So instead, I would recommend not using the add columns here. So I remove this column again. Remove, new column, delete. Here we go. Yes, I want to delete this column. Yes. And instead, enriching my definition here. So there's a DAX function, add columns. I can add a column to my table expression. My table expression is the table, the date, the calendar, right? And I just want to indent this a little bit and then paste in the code previously written. Please, IntelliSense, go away. Let people read what I'm writing here, right? So this would be the year, and then I add this column here. And then I could also add the month number, which would be the month on my date column, right? And I would add, for example, the month, which would be the format function, right? There's a really cool function, format, where I can pass in, for example, 4m's. This would mean, please show me the month written as the name, right? January. Or I could use only 3m's, and they would be abbreviated, Jan, Feb, and so on. Or 2m's would be 0, 1, 0, 2, 10, 11, and so on. Or m would only be one digit, right? 1, 2, 3. That's very cool. This is also, you can provide a local, right? I'm not sure where you're living, but I'm living in Austria. So for me, for example, would be German as the local. So I can pass in, and then you can learn that Januar would be the German version of January. But Austria is special. I live in Austria, right? I can even provide the Austrian local here, and then it would be Jena with this umlaut here, Jena instead of Januar. So this is very useful to provide any like reformat any date to anything into text or whatever, and you can combine things as well here, right? I think I will keep with English, so that's the common language here. I could also provide something like having the year here and having a comma, whatever, right? So you can build up several month columns, right? Don't stick with just one month column. If there are several versions, depending on the report, the audience, they need different things, then feel free to use the format functions for that, right? If you use the weeks, very important, there's this week num function. Week num function. There's one parenthesis too much. The week num functions, week num. We can also provide the date here. Very important for people living in Europe. I'm not sure who of the audience lives in Europe or the rest of the world, but in Europe, the definition of the week is different compared to the rest of the planet. So in most of the world, right, the first week of the year is the one that January 1st falls into, and I think this is the most most understandable version. But Europe is different here. In Europe, we define that the bigger portion of the week, whatever this is, this falls into the first year. So the 1st of January might be still like in week 52 or 53 in the previous year. So we have a different definition, and you do this by specifying 21. So 21 is a hint for the week num function to do as we are supposed to do in Europe, which is the ISO definition, the ISO definition, International Standard Organization definition of the week, which is a little bit confusing because in many years, the definition of the year, of the week, might be the same. So if you're doing this definition wrong, it might take a while before you discover that something's wrong in here. So for most of the years, it ends up with the same week number. But I think 24 was another year where it was special. So 24 would be a good use case to synchronize definition of the week in your semantic model with the definition of the week in the rest of the reports and the rest of the organizations. So this is what you can do here, right? You can also build the quarter and so on and so forth. And if you do so, be careful with that. So if I now use the year, we get this very beautiful column chart nobody would expect, right? It tells the sum of year. So it's calculating the sum, and as you can see, there's the sigma symbol here. So we have to solve this by going to the model view. That's the easiest way, because then I can shift click on many of those rows and tell it, no, don't add up those numbers, right? The year, the month number, the week, it's nothing you need to add up. But under advanced, the summarized by, I want to change to none, right? I do not want to add this up, right? Remove this again, add the year, now I get a list of years. That's one of the things you have to tackle. The other thing is, if I use the month, right? Adding the month here, go away. Adding the month, then I get this really nice list of months, which starts in April and ends up in September. And I'm not sure that this makes sense for anybody, right? Why is this? And this is the alphabetical order of the months. So April is alphabetically the first one, and September is the last one. Really, really hard, right? This would be homework for you. List the month names, all 12 months in alphabetical order. This is really hard to do because we're used to have this numbering in mind, right? January is the first, December is the last, June is sixth, and so on and so forth. That's what we learned. And we can easily change that here. So, but we have to tell because Power BI only knows this is text, right? And if I show a text, of course, it's ordered by this text. But in the column tools up there, so if I click column, I get the column tools in here, and the fourth to last is sort by column. And I can tell it, please order the month name by month number. And then I immediately get the correct order. And the last but not least, if I would have more time, I could show more of those things, is that you should mark the date table as a date table. In this case, it's not really necessary, but I think it's easier to just do it all the time, right? Always mark your date table as a date table instead of having the long version in mind. So mark as a date table, I just turn this on, and the list is easy to do, right? Because it will show you all the columns of data type date, and there's only one column there, so date. Save, and that's it, right? Then the date table is done. And we need to make sure that it's also connected in the model view. So I have the date here, I have the date here, and then I connect those two with each other. It's a many to one-to-many date to the financial table. Very good. So save, and that's it, right? Then just recognizing I'm really running out of time, so I have to speed up a little bit. Yeah. But before we step to the next step, I go to the next step. Again, I jump over to my DAX Studio. Give it a new window here, no connection to the same data model, which is this one, the untitled. Come on. Okay. What did I do wrong here? Then we jump over to this DAX Studio, cancel here. Okay. This would be bad. I would really want to show you the differences in size of the data model. So coming here again, no. That's not very good. Okay. Yeah, don't have time for that. So it should show you that now that the financial table gets much smaller. I think now we are at 2 megabytes instead of 5 megabytes, and we got rid of these extra tables. And the table is not very big here as well. The other thing is now, and in the reality, in the real world, this is the hard part, right? You have to walk through the tables, through all the tables, through all your columns, and find out, is this something you want to aggregate on? Like COGS is cost of goods. Yes, we want to aggregate on that, right? I want to see the numbers, an average or whatever. Country, I do not aggregate on country, right? I want to like filter on the country. I put this in a slice and a filter. I do cross filters. I would put the country on the axis of a bar chart or column chart. I would put the country on either the rows or the columns of my matrix, of my pivot table. So this is something what we call a dimension. Everything we filter on is a dimension. Everything we want to aggregate is a fact. And never ever store facts and dimension in the same table. Usually you put dimension attributes in one table together, which like force them together. But in this simple example, I will build something which called, Ralph Kindle calls it a chunk dimension. I don't like the name, but the concept is nice. I put all the dimension tables in one table. And that's what I will do now with the help of Power Query. So jumping over to Power Query in the, where is it? Transform data. This is what we should have done at the very beginning, right? Don't load anything there. I would now go through the names. I would check the data types. Be aware that like the 1.2 is a decimal number, which is not very good because it's a floating decimal number. There might be roundings. I usually change everything to fixed decimal number, which is though limited to 4 decimal places. So if the precision should be more than 5 digits, then stick with the decimal number. If you can live with up to 4 decimal numbers, please use fixed decimal number. It's more precise. It compresses better. Everything will be faster and smoother. So I now will like stop the load for this one, because I don't want to have this financial table. I want to have two different tables, and I will reference this table, and I will now create my filter table, right? Call it filter here, and then we'll go through all my things. I already did the homework for you, so I can now go through my choose columns dialog here. And then I know I don't need everything here, but I need a segment, the country, the product, the discount band, and the manufacturing price. There might be discussions about the price. Should this price be stored per product? Currently, there's only one price per product, so it might make sense. But it means if the price sometimes change in the future, maybe the reports in the past will change if they're referring to manufacturing price. So for the price, there's no clear solution. Something you have to discuss again with your domain owners, if the price might change and what's the consequences out of that. So maybe you want to change store the price with the dimensions in the with the product in the dimension table, or you want to store it together with the facts to have like historic versions of the price. Maybe you also want to share there and there to like have the latest version in the latest price in the dimension table, and the changing prices, the history of the changes in the fact table. There's many solutions available here. So I click OK here. That's what I get then my dimension table. And of course, I want to remove all the duplicates. I only want to have like distinct combinations of that. So we end up with 372 rows out of the 700 rows. And then I do the very same trick with the financials again here. I will reference this table. I will not duplicate all the steps, but just reference it. This will be my KPI table or fact table or whatever you want to call it. Sales, financials. Financials already given, right? So that's why I'm using a new name here. And then do the same thing here. So choose the columns, and I would now remove the segment, the country, and so on. But if I do remove them, how can I later know what kind of sales or cost of goods I had within a certain country? All right, I need something to reference back. And in Power BI, you cannot have references or relationships in the data model by more than one column. So one solution I see often is that people then concatenate those things, right? They like put all these things, right, and make a new column, concatenate everything here. The backdraft is here that you have like this long string, right, which doesn't compress very, very good, and you store the string together in the fact table and in the filter table. And one idea why we move things back away from the fact table to the filter table is to save on space in the fact table. But if you need still this long string, we're not saving any space, right? So instead, I would do the following. I would go to the filter, back to the filter table here, and add a surrogate key. A surrogate key means that I add a column which just gives a unique key to all my rows. In this case, it's just an index starting with 0. Every row now gets its own numbering in here. That's a surrogate key. And in the KPI table, I'm referring to that. And you can look it up through my home and then merge queries. I can merge my KPI query with my filter query, right? And then referencing this index. Left outer join is a very good idea. So I'm really very proud that Microsoft had this as a default. It's also a good explanation. Nothing is lost from the KPI table. It's just enriched with the idea from the filter table, which is good. And then I do the OK here. No, I have first have, of course, to connect those things, right? I need the segment here, and the segment here. Sorry, I clicked on the index. I didn't want to click on the index. So segment, then the country. If a control click, I can select several columns, right? As opposed to the model view in Power BI, I cannot connect several columns, but here in Power Query, through the merge, I can do so. Only make sure that the numbering besides the column name matches, right? Otherwise, you would connect the product with the discount band, which will not lead to any success, right? And say, okay. And then I get a full table in here, and I don't need the full table, but I only need like this index, right? And I don't need this prefix here. So just call it index. So now I know for which row in my KPI table is now connected to which country and so on and so forth. And now I don't need this country column for anymore here. So I cannot choose the columns and then remove everything which is already in the filter table, right? The country, the product, the discount, and the manufacturing price. I keep the index. This is how I change look it up, right? The index is the primary key in the filter table. The index is the foreign key in my KPI table if I want to know this more precisely. And the year and the month number, the month, I can also go away here because I already have this in my date table. I do not want to store it repeatedly in my fact table, which is usually a long table with many rows, right? So clicking OK here, choosing close and apply. And of course, some of my reports or things will fail because now the financial table is not there anymore. For example, my date table will fail because I'm referring to my financial table, which is not available anymore here. And I think Ctrl Shift L, I can then like overwrite every appearances of this thing. Just learned recently, so maybe you also use this Ctrl Shift L. You can change one thing and change it several times. There. So now I've got my filter table, the KPI table. Let's look up if DAX Studio now reacts again, or is it still dead? Okay, DAX Studio is dead for some reason. Maybe it's an older version or whatever. Cancel. Oh, that's really bad because I really wanted to demonstrate how now the model shrinks. So in the end, instead of 5.3 megabytes, we will have like, I think it's like 120 kilobytes. So it's like a fifth, 50th, like really, really tiny, right? And of course, the mileage may vary depending on your data, but it really, really makes sense to think about that. The smaller the model is, the smaller the file size will be, the smaller the memory footprint will be. So there's more likely that you really can work with the data because your laptop might have limits on the memory available, but also in the Power BI service. If you publish to Power BI service or Fabric, depending on the model you're having, there might be a restriction of 1 gigabyte, 10 gigabyte, or whatever of the size of the semantic model. So size matters in case of our semantic models. And furthermore, and this would be the last thing before I open up for questions. Is there any question here? Can you with Fabric, TSVGL, how can I decide which engine to use for cleansing, shaping, and loading data into a star schema? It's a very good question. I personally prefer to do it as close to the data source as possible. This means if my data source, if I'm lucky enough that my data source is a data warehouse, some data engineers already built something for analytic purposes, I would do the transformations there. That does not mean that the data warehouse itself has to be a star schema. Some data warehouses are like in a normalized fashion, right? They only like load data from different data sources, but still have it in a normalized fashion, which is not a star schema, which is okay, right? But then I would build views in this data warehouse, like in a schema I call Power BI or reporting or analytics or whatever, and put their views in there and do all the transformations there. So like the views, they look like a star schema, and then I just load the views into Power BI. I don't do anything in Power Query, just add my measures in DAX, but that's it, right? All the information I would prefer having there. But this might be different, right? If you don't have a data warehouse, if you have like Excel files as data source, then use Power Query. If you have a data lake, maybe it's a good idea already to put some Python code or Spark SQL or T-SQL notebooks to transform the data we have in a data lake to put out the lake tables, the tables in the data lake, right? Which then can be part of your semantic model. So it really depends on what's there, and of course your knowledge, right? What tools you're familiar with. So if I come into a company, I try to not like just put what I like to do, right? But like find out what's like the what's the skills with the customer, right? Because when I leave the project again, I'm external, right? I'm self-employed. If I leave the project, I don't want like to leave a disaster there. Nobody can maintain. So I have to listen and to find out what kind of tools knowledge is there and skill set is there. So I adjust my skills to build things so it makes sense for my customer. So in here, the last step that I would do, so we can further decrease the size of this data model, is because like cost of goods and so on, this is good, but like the cross sales, right? The cross sales is nothing else than the sale price times the unit sold. So this is redundant information, so we can get rid of that and therefore again decrease the size of the model. And yes, if we remove this column and build a measure where we calculate the gross sales, this will not be faster, right? Adding up numbers is of course faster than recalculating a multiplication. But that's very, very important. But the difference in time might be surprising low. So the difference might be in milliseconds or hundreds of milliseconds. So nobody of your report users will ever recognize that you remove the cross sales column and rebuild it as a multiplication. So I tend to remove all those things. Maybe if there's complicated calculations, complicated KPIs you have to calculate and measures, maybe one last step would be to again add intermediate results. But this would be the last thing, right? So I would remove those columns. Of course, again, I did my homework, so I know how to calculate this. Please make sure to talk to your domain experts. Please double check, right? Build a report where you show the column and show the measure side by side. I'm just running out of time, 5 minutes left. So that's why I just remove this enter profit, right? And I will also remove this column here, delete from model, and then replace it with measures, right? Add another measure here, a new measure, and tell it this would be the gross sales. And the gross sales, as remember, is a multiplication from maybe last week, if you have watched my video last week or the Fabric Cafe last week. And for multiplications, we need to use an iterator function, the sum x function, over my KPI table, where I ask for please take the price, the sale price, and multiply it with the unit sold, right? Units sold. And then another one, a new measure where I ask for the sales, and the sales nothing else like the sum, like the gross sales we just have calculated minus the sum of the discounts. And if I would have more time, I would replace the discounts again, hide this column, replace it by a measure. You should not use this implicit measure is called, because if you're late, maybe people connect with Excel to your data model, then there might be limitations what they can do with this implicit measure. It's now better since October last year, but still there's limitations. And if you later come to mind that maybe you want to add or use calculation groups, if you never heard about that, look it up. Very, very powerful feature in Power BI. But as soon as you introduce calculation groups, the implicit measure will not work anymore. And again, breaking your reports. So please, 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 for every of the columns, either replace it fully, right, with that you delete the column, or if it's just summing up things, also create a measure for that. And the last one would be the profit, new measure here. So the profit would be the gross, the sales, of course, the sales minus the sum of the cost of goods, right? And again, now I remove 3 columns from my big table, from my fact table, so this should decrease the size of my model. And still, everything is there, right? We did not remove any information. The information is still the same, but now we have a star schema, a filter table, a KPI table, and a date table. With 3 minutes left, I'm jumping back to my slides and try to sum up things. I think Morpheus right here. You have to let it all go, Neo. Fear, doubt, and disbelief, free your mind. And it clearly, this also speaks to myself, right? When I started with data warehousing, I thought there's something wrong, right? How can you have like the product group together with the product name, right? There's redundancy in there. This has to be normalized. No, it has not, right? For an application database, yes, but for Power BI, for analytics, we need a star schema. Star schema is superior when it comes to Power BI because everything is optimized for Power BI, is optimized for the star schema. So data model is important also in Fabric, right? No matter what kind of tool you're using there in Fabric, make sure that the lake tables or the tables or the views or whatever you want to import to Power BI is already a star schema. If not, then use Power Query. And just have seen this is easy to do, right? It was just a couple of steps in Power Query. So intellectually, from an intellectual perspective, nobody can say, "Oh, I don't know. This is too complicated." No, it is not, right? The complicated part is to really go through your information, your tables and columns, find out what's effect, what's a dimension, and then put it accordingly into a table there. And the same applies for the direct link, right? No matter what kind of tools you're using. And Star Schema is better. So your visuals will be faster, easy to create. Your DAX will be fast and easy to create. And of course, you can have ad hoc models, but if it's something you want to publish, then it's really important that you have a Star Schema running out there. So now I can welcome you to the team of the Guardians of the Star Schema. And nice to have more members in here. And are there any questions left?
Awesome, awesome. Thank you very much for the brief explanation of star schema, And guys, if there is any question, feel free to ask in the chat. If not, I have a question for you, Marcus.
Hmm.
So, you mentioned about you mentioned about some items, if I'm not mistaken, to that is going to be cause of a death of your
Yeah,
model, right? Your star scheme model. One of
yeah.
them was avoid fully normalization.
Hmm.
Uh, I've I've got to know how many actually how deep the denormalization should happen in a data modeling in this star schema.
Hmm.
Uh, the reason that I'm asking is because of some needs sometimes, if it is going to be recommended or not, about out triggered dimensions. I mean, when you have a dimension of product
Hmm.
and those products belong to a category of the products and a subcategory of products and then a category of product on top of that. So
Hmm. Hmm.
we have three maybe levels of the normalization in a transactional database.
Hmm.
But when it comes to the analytical one like this, what is your recommendation for these kind of hierarchies?
Yeah. So what you're mentioning is like these natural hierarchies, which when you normalize things, you split up in different tables: product table, subcategory, category, whatever, or regions, right? So there's like a city, and then there's a district,
Yep.
and then there's whatever, right? Um, if you keep it like this is called a snowflake schema. And the snowflake schema is slower because you load more tables, the refresh will take longer, but also the filtering has to go like trickle down from the main category to the category to whatever to the fact table. So it will be slower. So the recommendation is that you denormalize this. And on the star schema, sometimes it's also called denormalized schema. And when I heard this, like I like the concept of normalizing for application databases, but I don't like the name, right? I mean, what's normal in life, right? I don't think this was a good name, right? And if now think about a denormalized schema, it has like the double effect. Again, it uses normalizing as a normal or denormal or whatever as a term which doesn't really is a good term in my opinion. And the second thing is, does it denormalize everything? And it does not. So it's very important that you know if something is a fact or a dimension, because dimensions, they have to be fully denormalized. So you would denormalize all the information. So you will build, for example, in SQL, you build a view, select from product, join subcategory, certain category, and so on, and put all the fields into this one product view, which is then the product table in Power BI. But for the facts, you will not do that. So you want to get rid of all this detailed information and just use several keys, foreign keys to your dimension tables. So
Can we?
yeah, does this
Yeah,
make sense?
thank you. Yeah, that's awesome. Yeah, of course. Can we? I don't know. Can we say that or not? But as you mentioned again, Power BI is very optimized for star schema, right? And how about Snowflake? Let's
Mhm.
say, is it can be considered as a dead model, a dead schema in the today's analytical world?
Do you mean Snowflake as a star as a Snowflake schema, right? Not
Yeah,
Snowflake the
it's
database.
Snowflake schema. Yeah,
Yeah.
Snowflake
Uh,
schema. Yeah, not that it's
Yes,
Snowflake.
yes. The star schema is superior over the snowflake if when it comes to performance and anything. Yes, you should do that. I mean, there might be some rare reasons why you would not do that. So, for example, if the different information is coming from different data sources and I want to refresh them on different schedules, then you okay, that would be an excuse why you would not put it into one table. Or there's also this concept maybe for the products, you have like a date column in the products, which tells you when was the first sale, storing with the product. Instead of drawing the whole table, the facts when it was sold first time, you keep like an attribute there, right? But maybe you wanna not only show the date, but like wanna what was a new product in the year 2024, right? That is also either you add like a date and the month number, the year in the product table then, or the product table is then referring to the date table, reusing all the information already there. This is not called a snowflake. This is called an outrigger. This is something also,
Outrigger.
according to Ralph Kimball, is allowed. And this is something you have like to find out what's the best here. Is it okay if like make the product table wider by adding all those year, months, and so on, or if I want to really reuse the other table? In Power BI, it's much complicated. If you connect those tables, then you would end up like in a loop. Power BI will not allow you to create this, right? So the relationship between the date table and the product table most probably will only be allowed to be inactive. So you have to use DAX to use this function, use relationship to activate this when you need it.
Do you recommend that for the outrigger tables? Is there any alternative way to avoid those loops? It is
There's
sometimes it's going to
two
be
options,
really
right?
tricky,
Yeah,
to
yeah,
have those outrigger, when from a dimension you're referencing another dimension. Not really.
exactly.
I'm not talking about maybe, my first question was not in the right shape. I was not trying to talk about snowflake schema, right? I was trying to just mention about the outrigger, and but my example was not a good one. But yeah, for example, from products, we are
Mhm.
referencing to date dimension.
Exactly. Now dimension, yeah.
It
There's only
is.
two options, right? Either you model it as an outrigger, making your DAX more complicated in Power BI because most probably sometimes Power BI allows those things because it can find out the right way. Sometimes it does not. So there's a probability maybe it might shape that. If you want to keep your DAX simple, then the best thing will be to add those columns directly to the product table. And usually it's not much of a harm, right? The reason why we don't do that with application databases is because we avoid the redundancy. Because if I write often to a table, for example, if I make a mistake, I might only change some occurrences, but others not, and then we get like these anomalies that we have like different information in the database, which does not reflect what's in the real world. And there might be several processes accessing the database, right? There might be a full client, there might be a web application, there might be an API changing the database, right? And if there's some mistake, some bug in there, you end up with like misinformation in the database. That's why we want to avoid this in application database.
I
For
see.
Power BI or data warehouses, it's much easier because there's like there might be one Python script, or there's one SQL procedure, or there's one SSIS package, whatever. There's just one piece of code who makes sure to write, for example, the category or the product year into the product table. This is much more easier to test, right? And make sure that the data is still there as it should be. And the querying is much easier because we don't need all those joins, these different things. And if you ever like have written more complicated SQL statements, it's very flexible because every join can be like different columns, right? But there's also a chance of many mistakes, right? If you misspell like the ID or the key or whatever, and then you end up with a query which does not really work. And this is why we want to avoid all these troubles, having complicated joins. Also in SQL, right? If I can query with SQL a star schema, it's much easier than anything else. And of course, also in Power BI, it's much easier and much easier
Yeah.
to understand.
Cool. Awesome. And maybe the last thing
Mhm.
would be about the planning and gathering the requirements, which is very important, when we are
Yes.
talking about
Yes.
analytical solutions. In most of the projects I've seen, that they bring everything to the model. Okay, do you really need that? Do you want to report on country, for example? Do you want to report on this specific dimension? If you don't need it, so don't load it.
Yes.
Why you are bringing more data and making your file and your refresh time longer and bigger? So it is one of the, I think, very important topics and
Yeah.
that we can talk about maybe in another session, Marcus. I do really like to enhance my skills and knowledge about what data is required to be in a report and how big our dashboard and report should look like.
Yeah.
And yeah, cool guys. If there's any question, please feel free to add it in the chat. So today's session with Marcus is done. It is going to be available on our YouTube channel after this live, and you can just rewatch it and practice what Marcus just showed us. And for next week, next weekend, we will have Basland, who's going to talk about Python modules in Microsoft Fabric to just reuse them. That would be an awesome one as well. Feel free to. It is not announced yet on our LinkedIn page and meetup group, but stay tuned for its announcement and doing your registration. So again, thanks for attending. Stay tuned for the upcoming sessions, and feel free to subscribe to our YouTube channel to rewatch the past sessions, including today's. And on our LinkedIn page, you can just follow us for any announcements. If you would like to start a discussion, getting support from your peers and from experts, you can just join a Microsoft community group and just write your question and ask for support. In the meetup group, please feel free to rate today's session. It is going to help us to know what we can do better. And just share it with your friends, and on Reddit, feel free to just join there as well. Cool. Thank you very much, everyone. If there's anything to add, Marcus, feel free to add it. If not, we can wrap up this session. There was some just thanks from Arafat and from Rima. Cool. Thank you for joining. Marcus, do you want to add anything? If not, we can just say.
Any famous words? Yeah, of course, buy my book, but
Awesome.
yeah, keep on working on the star schema. That's the most important.
Yeah.
Yeah.
Cool. Awesome. Awesome. Cool. Have a great weekend, guys.